Is it recording? Yeah, it is. So make sure you don't round in this unit. That's very important. And they'll tell you that on the exam too. Everywhere you round except for in this unit. Okay. So let's get right to it. Some fill in the blanks. So accuracy, right? Some definitions. Accuracy refers to how close a measurement is to its target. To its target value. To be accurate, a measurement value must be close to the real value as possible, must be as close as possible to the real value. Okay, so that is one definition of accuracy. Okay, so this is where your study sheet might have to. So when somebody asks you, hey, how could you define accuracy? They might have multiple choice. The one that says something about being as close as possible to the real value is what is most accurate. If you claim you have measured something accurately, someone should be able to repeat it. Repeat the process and get the same value. Okay? If you say, hey, I think I'm pretty accurate, I should be able to give that tape measure to someone else. Be like, hey, you measure that thing. And if that person can replicate it, it's like, hey, yeah, we are pretty accurate here, right? Your measurement was pretty accurate. So in order to be accurate, for these two things to be possible, okay, guys, for someone to be able to repeat it and get the same value, you need these things here. We need to use a standard unit and use an appropriate scale. And there are your standard units right here. So anything you recognize in this world that is used to measure something, centimeters, inches, kilometers, miles, kilograms, milliliters, anything. Did you know that stones are also used? It's also a unit of measure. Did you know that? Somebody's weight can be measured in stones. Yeah, just use the back of this. How's that? The British like to use stones, right? Like that's how they measure their weight, or whatever weight it is they're talking about. So we need these two things, okay? So what is non-standard, you might ask? Well, if I were to use my hand span, this is a hand span right there, or my feet or something to measure something. If I use my feet, okay, and then somebody else, like, hey, I counted 20 from here to here, I counted 20 feet, and then somebody else, one of you, measures it with your feet, we'll have different answers, right? Yeah, I'm a size 14, right? Whoa, they make those? Yeah, that's how I feel. Like I always have to like beg them to go find one for me, right? But anyways, we would have different. So that's not a good. We would say that measurement is not accurate because you used a non-standard unit. You have to use one of these to be accurate. Okay. Another accuracy can also be affected by improper or careless use of the measuring device. Do I have a measuring tape here? Yeah, right here. So, right, this is my measuring tape. If I wanted to measure this remote and I don't make sure, is that on the screen there? I don't make sure that this tap makes proper contact. Like if I measure it like this, that's improper use, okay? If you measure flour, but you use that cup to measure something liquid before, like water or milk, it's technically improper use because some of the flour will get stuck on the side of the wall. I know that some of us don't care, right? It's like it's close enough for baking purposes, but that would be considered inaccurate. Okay. Also, a damaged or faulty measuring device could also cause something to be inaccurate. Hello? Okay. So here are some examples. That'd be another careless way to use it, or this would be good. Like you're shaving off, you're flattening, you're leveling off your spoon or whatever cup. This would be considered inaccurate. So you can say accurate, and this would be inaccurate. Why? Improper use. If I ever asked you, like, why is it that it's inaccurate? Because it's improper use of the measuring device. A cup is still right. This would be good. What's up with this ruler here? I don't know if you can see it. I tried my best. You see that it's bent? Somebody was playing with those, those flimsy rulers. If you use that to measure something, technically inaccurate. Why is it? A faulty, right? Damaged ruler, right? That's why you would say it's inaccurate. So it's either because it's not working properly or because you're not using it properly. Okay. Let's recap this page before I move on, because it's kind of like you just here you have it on your study sheet or not, right? So if I asked you, what does accuracy mean, right? Try being as close as possible to your target. That's what accuracy is in a nutshell. If something is accurate, right, somebody should be able to repeat and get the same value. How do you get that? You use a standard measurement or unit and appropriate scale. What do I mean by scale? I will explain that in a bit. We'll do an activity or we'll do some questions on that. So how can accuracy be affected? Improper, careless use, damage, or faulty measuring device. So this is all kind of jiving. It should all be connected. And hopefully, let's go over to page 3. And let's give this a go here. So I need to add more pictures to this one, to be honest, but right now we're just going to stick with what we have. So state whether or not each scenario would be resulting in an accurate measurement. So tell me if it's accurate or not. Explain, making reference to the unit and the scale. Okay, so we're going to look at each unit and the scale and then determine whether or not it's accurate. Okay, so the first scenario, using centimeters to measure someone's height. Centimeters, it's standard, right? Standard unit. Check, right? So that part is good. Would it be appropriate to use centimeters to measure someone's height? It is not outrageous, right? Let's look at it that way. It's not outrageous, right? Appropriate scale. Oops, scale. And right, inches, centimeters, meters, feet, all of those would be within, right? So that's good. Therefore, measurement is accurate. Measurement would be accurate. We don't have the actual measurement, but we know that the conditions are right for the measurement to be accurate. I hope that makes sense. Because guess what? Because of these two things, somebody could repeat it and get the same measurement, right? So I'm telling you that the province always finds fancy ways to test your knowledge on this. So I'm trying to give you a picture, and whatever they throw at you, you should still be able to answer it, right? Sometimes it's just a quick multiple choice. Sometimes it's like explain, like you actually have to explain a little bit. So they've had pictures of someone using a measuring device and they weren't using it properly. So as long as you knew it's not accurate because the person isn't using it right, bingo, you got your full mark there. That's all you needed to do. Let's do a couple more and then I'll let you do the rest. Using your forearm to measure the length of a picnic table. You should say not standard. Okay. What happened there? Standard. Not standard in terms of unit, right? The unit is not standard. So, right, it fails there. Technically, you failed, like it failed already, but we're just going to continue. The length of a picnic table. Technically, the scale is okay. Scale is appropriate. But because it fails, like it fails either one of them, it's not accurate. Okay? Measurement. Inaccurate. Is not accurate. You can say that too. Okay? So you're making your conclusions based on that. And what would be the problem here? You couldn't replicate, right? Let's make a note here. You could not repeat the process, okay? And get the same answer. That's why that's a problem there. Can you try everything from C to F? See what you get. Kind of like the same idea. So check for the unit and check for the scale, and then see if you would say whether or not it's accurate. Right. Let's see how you did. I'm gonna do a shorter version here, okay? So using a meter stick to measure or calculate the distance between two cities. It's supposed to say 2 here. Sorry. Autocorrect. Okay. Meter stick, it is standard. A meter stick is actually a standard unit of measure. But the scale is not accurate, is not appropriate, right? So not accurate. Okay. Using a ruler marked in millimeters, that is standard unit. So that's good. To measure the width of a textbook, what do you think? It's good. It's okay, right? Scale is also good, therefore accurate. You know what millimeters are, right? Because these days, I don't know if students. I'll hear my ruler. Where's my ruler? Right. The smaller ticks here are millimeters, right? So that's okay for the width of a textbook. So accurate. Next, your stride or step. Not standard, right? Not standard. This one. To mark off the volleyball court, this scale is actually appropriate, but the unit is not standard, so therefore not accurate. You might disagree with me. It's like, no, that's how I make my volleyball court. But in this course, it would not be accurate. Okay. F, using a tablespoon to measure the amount of sugar required for a cake. Standard. A tablespoon is actually standard. And amount of sugar for a cake, the scale is also okay. Both of them are okay, therefore accurate. Now, I think some of you could probably argue with me. It's like, well, not all tablespoons are the same. There's actually like a standard. I would probably grant you the marks there if this had been for an AC, because it would have to be specific, right? But if a recipe calls for tablespoon, that's a standard measure. Okay. All right, let's keep going. So I'm not going to do this one yet. Maybe if time allows, it's just to get you thinking a little bit. So we talked about accuracy. All right, guys, accuracy. Now, this is going to be front and center every single time. Precision and uncertainty. Okay, so you're ready, right? You're writing stuff down. Precision refers to the smallest. This is on page 5. The smallest increment on a measuring device. I will highlight that because if you have this on your study sheet, same as the other one for accuracy, you're probably good to answer pretty much anything that's thrown at you. Okay. Another way of saying this is that the precision is the smallest amount by which a measuring device can go up or down by. Okay. Every measuring device, no matter how precise, will have a limitation. Precision essentially states what the limitation is. Okay, can I highlight that as well? That's another good way of thinking of precision. So NASA might have like the most sophisticated apparatus to measure something, but they still, at some point, it's limited. It can't go, it has to round at some point, okay? Uncertainty. Uncertainty. Due to the fact that every measuring device has a certain limitation, there's always some uncertainty. All measurements have the potential to be off, regardless of the precision of the measuring device. At some point, you have to round up or down. This is called the margin of error. Okay, I want you to highlight that. I want you to, like, that goes with uncertainty, basically. Okay, the margin of error, how much you can be off by. And I'm going to use a different color for this next one because I want that to stand out. Uncertainty is always half of the precision, unless otherwise stated, of course. And there it is. Here's that what you just highlighted is represented by this formula. Add to your study sheet. Okay? Add to study sheet. You see that it's usually plus or minus on the side here? There's usually a plus or minus in front of that number because you could be off on the high end or on the low end. I brought, I might bring some more goodies to show you, but I think this one does. This is a kitchen scale, okay? And I would like you to see what I mean by the precision. Like there's a smallest amount it can go up by. And then at some point you round. So I'll take this off for a bit. I'll bring it back. Can you see that? It's very faint. I know. I'll try something here. I'm gonna go different units, grams. There we go. Okay. So let's say I'm gonna measure this. This one is very precise, by the way. Let me try something here. Can you see that? Okay. So if we measured this, it's 0.007. Okay. Is it possible that it's actually yet even like there's a number out here, like past the 7, this device just doesn't include it? Yeah. It just, so basically what it did is it rounded it. This thing rounded it, okay? So if you want to make it a little heavier, I'm going to grab my sticky note here. Let's see how heavy this thing is. I'm going to just add the sticky note to the scale. Not yet, okay. Oh, there. Oh, do you see that 6, 7 going up and down? It's rounding. It's rounding, right? So the precision lies right here. This is the smallest amount it can go up by, okay? Let me try something else here for you. Let's measure my calculator. Let's see how heavy that is. Well, that's a pretty good one. So if I added some sticky notes to it, no. What else do I have that is just more sticky notes? How's that? This is going to be heavier probably. There, it goes to 101. But regardless, guys, pay close attention to this. Regardless of what this number is, look up here. It's the precision is here. This is the smallest amount it can go up by, which is 0.001. Right? If I made it just slightly heavier, I can't do slightly. But right, like the action actually happens here. That's what I want you to remember when it comes to precision. It's on the smallest increment, okay? So let's go back to our notes. Page 5. Let's make it a bit brighter here. You're expected to state the precision and uncertainty given the following. So you could be given a picture, right? An actual measurement or words. Okay. So when it comes to a picture, you're going to state the precision first. And this is how you find out. I'm going to grab a highlighter for this. What is the smallest amount this is going up by from marking to marking? What does it go up by every single time? 10, right? Plus 10, plus 10, plus 10. So it goes up by 10 every time. So the precision in this case is 10 milliliters. Okay, you're done. That's the precision. You get a mark for that, by the way, guys. 1 mark. What's the uncertainty? Go back up to this orange box that you just highlighted. What does it say? Uncertainty is taking a precision, splitting it in half. So we're going to go 10 milliliters, divide it in half, and then we say, well, the uncertainty is plus or minus 5 mLs. There we go. You've got your precision and your uncertainty right there. Okay? So anything you measure, we will assume that we're off by 5 mLs, either on the higher end or on the lower end. Let's go over to the actual measurement. You're going to zoom into this one right here, the last number that you have right there. Precision found here. Okay, exclamation mark. This is what I need you to understand. The precision is this. You copy that number. I'm just going to do a silly example at first. I'm going to copy that number. I'm going to put zeros everywhere except for where the precision is. I'm going to put down a 1. And you're like, Mr. Dixon, there's a 7 there. Why did you put a 1 down? Because what I'm telling you is that based on this measurement, okay, the smallest amount this device can go up or down by is 0.01. Okay? Here's my explanation to you. Let's find the uncertainty first. Uncertainty is 0.01. We now drop the first 0. We don't need it. Let's divide that in half. Grab a calculator. If you have one, we go 0.01 divided by 2. That's 0.005. Just like that. Do not round. So plus or minus 0.005 centimeters. Units everywhere. Okay? Units everywhere. Extend this. And I will explain. Explanation. If this is the number that I read off of the measuring tape, or whatever device I use, this is the number that's on my screen. This thing, if this item had been just a little bit longer, it could have been 55.28. You notice that? It would have gone up by 1 right here on the second decimal. If it had been just slightly shorter, it would have been 26, right? So minus 0.01, or you could have gone up by 0.01. And so it's this number that you want to focus on. This one right here. Doesn't have to be, right? It happens right there on the last decimal. Okay? And it's always going to be 1 when you read it off of a number. Okay, no matter what you do, if this had been a 9, a 6, whatever, you say, no, it lies right there, it's 1. It's going to take some practice, but that's okay. Words. Ruler is marked in half-inch increments. When it says that, your precision is, how would you write half-inch? You just go like this, half an inch. Or 0.5 of an inch. It's up to you how you want to write that. Okay? You got this? Precision is half an inch, which is that. How would you write the uncertainty from that? Remember this? Uncertainty is always taking your precision, dividing it in half. That would be plus or minus 0.25 of an inch. There's your measurement, your precision, and your uncertainty stated right there. So 3 ways that you could be asked to find the precision and the uncertainty. There could be a diagram, just a number, and you hone in on that last one, or in words where they just tell you straight up that this ruler is marked in half-inch increments. Okay. All right. Let's practice this. I need you to practice this. Let's go to 6. You're with me, right? You just need to get a few more examples in, and after a while, trust me, you're going to be pretty good at this. Okay. So look at the picture here. What am I going up by from one marking to the other? If you had to guess, or if you're looking at this, what do you think every marking is going up or down by? Can we say 50, like 100, 150, 200, right? This is going up by 50 every time. So we have a 50 there, a 50 there. We're assuming that the precision here is 50 mLs. Okay, that's what you want to write down. My uncertainty is what? Always your precision divided in half. Can I tell you something? If you get your precision wrong, but you divide it in half to get your uncertainty, you're still going to get partial marks. Okay. Precision 50, uncertainty 25. Stay with me, okay? You'll get some more time in a bit. Next, if you had a measurement 6 feet 2 inches, if I give you $100, no, I don't have that much money. What would you say the precision is here? What's the smallest amount you think you can go up or down by if I gave you this thing? If I would be a little bit taller, it would be 6 feet 3 inches, right? If you were a little shorter, it would be 6 feet 1 inch. So your precision here, you hone in on the smallest unit. So this is actually just 1 inch at a time. This thing we're assuming only goes up in 1 inch increments. Okay? Your uncertainty, therefore, you take the 1 inch, you split it in half. Guess what? You get half an inch. That's the uncertainty. Oh, I'm going to use this as an example. So that measurement, guys, pay close attention. We can now say, we would say 6 feet, 2 inches, plus or minus 0.5 inches. We would take the measurement itself and we would add or subtract the uncertainty. Okay? Write this down. This is the measurement, and this is the uncertainty. Because when you buy a can of pop, what does it say on there usually? How many milliliters? 355, I think. 350, 355. Do you think it's 350? Bang on. Do you think there should be a plus or minus? 355 plus or minus? There should be. We're not used to it, but technically there should be. One more here. A measuring tape has markings of a 1/4 inch. Okay. We assume, write this down, we assume that there is a 1/4 inch increment. That's what we're assuming. Therefore, precision is a 1/4 of an inch. I don't like fractions that much, so this is what I do. Watch. A 1/4, I turn it into a decimal. So the uncertainty is 0.25 divided by 2. What do you get if you divide 0.25 in half? Try it. 0.125. Try it, right? If you don't believe me. And you're like, what about the plus or minus, Mr. Erickson? It actually, they will not take marks off if you forget the plus or minus. But it's technically supposed to be known as, you could be off on the higher end or the lower end. Okay, I'm going to ask you to try 6, at the bottom of page 6 there. Let me just see what's behind this here. Yeah, we're just going to do that for now. Try to come up with the precision and the uncertainty for all these 3 scenarios here. Try your best. Write something down. Use pencil. If you're wrong, big deal, right? It's not going to be the end. Yeah. Question? If you already... Okay, we'll do a couple more here. I feel your pain. Okay, I feel your pain. It's a dry unit, but we can do it. Okay, watch this, guys. Watch this carefully. Some students just like to kind of estimate what that is, what you're going up by. I'll give you a formula here, okay? So I will erase this. If you want to put it under this, that's up to you. So precision, this is what I say. I go high minus low, okay? And you put that in brackets, divided by number of gaps. I use this when I don't want to guess. I use this formula. Okay, so make sure you write that down, highlight it. I'm going to highlight this so it stands out. What do I mean by that? Grab any 2 numbers that you see, call them high and low. Okay, so I'm going to use orange for a high one. So in this case, I'm going to grab 30. This is my high number. And then I grab a low number, which is green for me, 20. You could have picked 10 if you wanted to. It's up to you. And then you divide it by the number of gaps in between those 2 numbers. So watch, there's, in this case, there'd be 1, 2, 3, 4, 5 gaps. Okay. So I'll call this high, low, and 5 gaps. Say, what? I just figured it out by myself, Mr. Erickson. I don't need the formula. That's okay, but sometimes you'll come across some tricky ones. So I would still say have this one on there. So your high number is 30. Your low number is 20. Make sure you put that in brackets or else it all goes down the drain, okay? How many gaps? I counted 5 gaps between the numbers, okay? So here it is. Let's put it to the test. So that would be 10 divided by 5. So precision is 2 what? What are my units? Minutes, right? Yeah, it says it right here that it's minutes. Test it. Check if it's right. Go anywhere. Go 40. Let's go up by 2. 42, 44, 46, 48, 50. It works, right? So now you know it's 2 minutes at a time from one marking to the other. That's what they want, guys. The smallest increment. Units. Uncertainty. 2 divided by 2. Well, that's easy. That's just 1 minute. So this is what they were really after. 2 marks right there, just for you figuring out your precision and your uncertainty, okay? All right, let's go over to the actual number. Where is the action happening? Right here. So you copy, everything is 0, guys. Everything is 0 except for the third value. You put a 1 there and slap on the units that are being talked about, okay? Uncertainty, 0.001 divided in half. What do you get there? 0.0. I'll show you before I do it, because sometimes students are thrown off by as many zeros as it can't be right. Yes, it can, right? So this is your uncertainty, 0.0005. Are you very uncertain here? Not much. Like, you're actually doing pretty good. Like, your uncertainty is almost negligible, right? Your precision is very good. Like, you're very precise with this device here. Whatever you use, we don't know, right? Okay, next one. Measuring cup marked, you know that in this, right? So increments, 125 ml increments. That's what that translates to, okay? So my precision is automatically 125 milliliters. That's it. Uncertainty is 125. Guess what? Some of you are going to make your study sheet. I hope it's not you. You're going to be like, oh yeah, I'm going to write down this example. It's 5, so let's divide it by 5. Right? No, uncertainty is always half. It's always half of your precision. Okay, and that is what? Plus or minus 62.5 milliliters in this case. Okay. All right. Your task, all right, is going to be, come with me. I'm going to take you to page 8. And you're going to write down at the top that your homework is going to be pages 8 to 14. There's not a whole lot of resources, or like none, for this unit. So I just went around my house, took pictures of random items. That's what they do quite often, the province. And you have to come up with the precision. I want you to come up with the precision and the uncertainty in every single case. Every single scenario, I want you to come up with the precision and the uncertainty. What do you think it is for the first one here? 5. It's 5 mLs. It just says, could you use the high minus low divided by gaps? Yeah, it's just way too much work in my opinion. Right, so I'll give the first one, it's free. Here. Uncertainty, Well, 5 divided by 2, it's plus or minus 2.5 mLs, just like that. If you get this concept at the end of today, you're doing pretty good. Because in terms of math, this is all we're doing today is we're figuring out the precision. From there, we get our uncertainty. It's the margin of error. Let's write it down one more time. Margin of error. So it's basically that's what we're allowing to be off by. Anybody recognize what that is from? Anybody? Yeah, Tylenol for my kids when they were younger. We've got like 50 of them because every time you buy Tylenol, you get one of these. What would be the precision on this one? Actually, very easy. How much? You're going up 1 teaspoon at a time. So my uncertainty is plus or minus half a teaspoon. You can write plus or minus 0.5 of a teaspoon. That's fine. It's okay to go decimal if you don't like to state it in fractions. So that's your task. From 8 to 14, it seems like a lot, but you can actually hammer through a lot of them, if not all of them, before the end of the class. Okay? And if you need help, I'm here.